Greetings, New Relic User Group. This is my presentation for the New Relic User Group 2025 here in the Twin Cities. The title's kind of fishing with New Relic, Open Telemetry, and a bit of Gemini CLI, Claude, and Qwen3 Coder. We're going to be doing a whole bunch of stuff, but the general theme is going to be AI coding and New Relic. So what's our goal? It's always good to start your stuff off with a goal. Our goal is going to be to build just a nice functioning app in the cloud. We want to avoid ClickUps. As much as possible, avoid doing anything where you have to click through a cloud console. So use infrastructure as code for documentation and traceability. I want to also gather performance metrics from the app. We're going to try to gather some usage metrics from the tools, find out how are we using these things? How much is this really costing me? And then we're going to look at some cost metrics from the cloud, maybe some costing tips, but we're going to get there with some monies aspects to this whole thing. So we can find out, was this really a good usage? All right, so the app. I'm heading to the boundary waters, and I would like to know the best kind of lures and tactics for the fish I might encounter. I thought this would be a useful app. So the first thing I want to do is, before I do anything with Gemini CLI or any of these other tools, I want to figure out the telemetry side of the house. So the key challenge with getting that telemetry data directly from Gemini CLI or Open Code or Alibaba Code or Qwen3 Coder or any of these is, because they all have kind of a similar telemetry block here, is that it just has an OTLP endpoint. And the problem there is, for New Relic, who ingests it on an endpoint, we kind of need to pass in a header that has our API key so New Relic knows who it is who's talking to them. So how do we do that? Well, one way to do this is with the Open Telemetry collector. The standard OTel collector we can launch with just Docker Compose. So here on the left, you see a Docker Compose file that has current collector. We're using the contrib at this version, but I think the latest would work just fine. And what you'll notice is I'm going to pass in my New Relic API key. Obviously, if you're doing this on your own local machine, you could just hard code it in here, but I'm going to pass it in. And the key thing to point out here is we got to open some ports. We got to listen to 4317, which is the gRPC port, and the 4318, which is the HTTP port. You can see that I'm putting this endpoint into my receiver too. So in each one of our Open Telemetry collector blocks, you're going to notice a common theme of receivers, how we get telemetry data in, processors, how we process it before we do anything else. So this is like where you could do drop things or filters or recombine aspects. And then we have exporters, so where to send it out to. So in this case, this exporter goes to debug, so just put it out to the log so I can see it, and send it out to the US-based New Relic endpoint. There's a European one too, for those that might be watching this and are in Europe. And you can see we're going to pass it that header key. This service block, which you'll find common, just ties it all together. So like for metrics, receive it on the OTLP, process it in these three ways. You can see trace, log, metrics. Exporters, debug, and OTLP. So it's like in, process, out, in, process, out, in, process, out. Now the thing that messes me up, and it messes me up every darn time I come back and I start to mess around with this, is all these collectors, or all these CLI AI tools, are talking in gRPC, which is usually 4317. But the URLs all have HTTP in them, which always makes me think that, oh, we're doing HTTP. Let's do 4318. So it just messes me up because they talk in 4317, but they put an HTTP URL, which in my brain immediately says, oh, we're doing HTTP, not gRPC. So that's just one of those things that catches me every single time. So here you can see I launched the Docker Compose up, and we can see that it's now listening on 4318 and 4317. The other way to do this, and it's actually on the same host, I might add, I just stopped one, started the other, is that we could do it with the Grafana Alloy collector. So Grafana has their own Open Telemetry collector as part of their full stack of collection tools. And what you'll see here is I'm doing a Docker run. There's a few ways to launch Alloy. I'm just showing you one. We mount the config file, we expose the two ports, we're listening on the latest. Because I know I need 4317, I'm saying make sure you listen to all addresses on there. and I pass it. Now, I will point out that when I was testing this locally in Docker, they didn't go through all the time. And I'm pretty sure it has to do something with this batch data needing to have a similar limiter because it's the amount of verbosity that goes through. But I'll point out that I've also done Alloy in Kubernetes, which I tested with for this. And the config file is identical to the prior one. I put in boldface, when you switch from Docker to Kubernetes for Alloy, the key thing you got to be aware of is that it needs these other discovery pieces. So this bold is really the only difference between launching this with Docker and launching with Kubernetes is this. The other piece that I'll point out outside the default values for Helm is you got to tell it to open up those ports. By default, the Grafana Alloy collector doesn't open up the OTel, the Open Telemetry gRPC, HTTP, or in my case, I also like to ingest Zipkin. It doesn't open up 9411 for Zipkin. A little pro tip is here's a little one-liner that I always put in my code that basically says delete the config map that has this config, create a new config map from the file with the config, because I'm always messing with it, and then get all the pods, delete all the pods, because that forces them to pull from the config map, wait for 10, and then get a list of the pods. This is like my one-line piece of code to rotate my Alloy pods and make a pull in a fresh config map. Because a lot of times I'm messing with the settings. Here you can see me getting the services. The other thing I'll point out is I did a node IP service that points to the same services. That's what this Alloy service node port is about. That way I can send things like any one of my clusters computers on 3921 will go to 4317. Any one of my collectors computers on 31235 will go to 4318. That's what a node port is. It opens up a high numbered port on every one of the nodes in your Kubernetes cluster. So this is just another way for me to ingest data in a straight TCP way. Otherwise, it goes through my Nginx ingress controller, which works for HTTP, but maybe not so great for gRPC. Hopefully that makes sense. Just know that coming into my cluster, any node on 3921 is going to hit 4317 for that service and go on to Alloy. So how do we send Gemini telemetry data? Actually, you're seeing both cases. So any value you put in here that isn't a real one is ignored. So I just kind of use the word old to kind of comment out a setting. So I can send the OTLP to my Kubernetes master node in-house with that 3921, and that'll go to port 4317 of the Kubernetes service for Alloy. Or I could go to 4317 on that Docker host, and that was the one I was launching with Docker, which will either be Alloy or the OTLP collector. So I'm using the Open Telemetry collector right now because it's working. And on Kubernetes, I'm using Alloy. So I can go back and forth. In both cases, they send the data on to New Relic. So, all right, good enough. I'm going to go ahead and start the work now. The work, we're going to make a directory, go into there, and launch Gemini. Gemini can be installed with Node.js. It's a straightforward tool. The same is true with Qwen3 Coder. I use Node 20. I think that you just need to use a more current version of Node. I also want to point out that you don't have to set those settings in a settings file each and every time. You can optionally pass them as command line parameters this way. So this is another way to capture telemetry data. All right, so let's get going. The goal here is to create a markdown file called requirements that has a fish section listing all the common kinds of fish found in the Boundary Waters Canoe Area Wilderness Area and Quetico Provincial Park. They're next to each other, so I just did both. For each fish, create a section that includes the name, the common types of lures, bait, and any notes on fishing techniques. Pretty straightforward. So I'll kick that out to Gemini Pro. And don't worry, I'll pause if it goes long. One thing I'm liking about this is it's searching the web. So the use of some of these AI coding tools like Ollama are rather static, but the ones that use quote-unquote tools mean they can hop off to things like Google search and get fresh data in on top of the model. So it's like called RAG for retrieval augmented I don't know what the G stands for, but it's RAG to bring that data in. So you see it's creating the requirements file and saving it. So the reason I do it this way is that way I get the requirements in and I can now iterate on them bits at a time. And I found it to be a really successful pattern for using AI coding tools. Get your requirements down to exactly how you want it and then iterate, iterate, iterate. And you can see that I've used 37,000 input tokens and 2,000 output tokens. We'll later talk about costs. But one of the things I like to point out here, you can see it right here, and this is true of Qwen3 and true of Gemini. 8,000 of those 37, 21% were served from the cache, meaning I wasn't billed twice for them. So the caching of these tools saves you a lot of money. We're going to see that. So here's the output it came up with. It has kind of a description, the boundary waters, certain fish that are in there. Now notice I'm not getting any pictures. This is just content, just written. So the big one I don't expect you to read. Just this is a zoom in of section of the one on the right. Next, some of my tips are to iterate bits at a time. So initially I said, do everything including an Android app. I later said, I don't need an Android app. I can just have a PDF print, which would be good for when I need to be offline with the same data. So I kind of iterated on it. Another one is, sometimes it wants to do some running a dev. Here's a case where I went to Midjourney and generated a bunch of fishing images that I wanted. And then I told it, go find the fish in this folder and tie it to the web page. And so here it was iterating through those fishing diagrams and adding it. What I'll often do is say, no, you don't need to run dev. I'll go run dev and see if it works and let you know. It's up to you to decide how long you let the AI tools go. Like for instance, here's a really great case. Here's where I could have saved a little bit of money, right? It is trying to launch create next app, and then it got a prompt. So it kills it and removes the web directory, and then it tries to launch it again. It gets a prompt. Oh, looks like I got more interactive. Kill it and delete the directory. It did like 3 or 4 times. And that's where you kind of ask yourself, is this really good for the company? Am I being silly here letting my AI tool just go over and over and over and over again? Because they can add up. All right. So what did we end up with? This is after I've added some images and iterated a few times. Nothing too bad. I have a web app here. It's got a title. I got some fish. I even added a couple fish that I thought would be relevant. You can see it's using the same image for both, and those images came from Midjourney, so I had an AI generate them, though I could have used Vertex AI, so Imagen too in Google. And this is great. I'm seeing the lures, I'm seeing the bait, I'm seeing some of the techniques. And what's interesting is some of these you're like, what is Dr. Spoons? I've never heard of Dr. Spoons. So you know that the AI tools are pulling from some manufacturer's site saying that this is the best lure for this type of fish. So when I see brand names in here, I treat it with a grain of salt. And obviously if I'm trying to sell this app or make it a big production, I tweak it up, right? The general lures and the general techniques are right. The other thing I was noticing with the React framework is that I thought, oh, a theme, maybe I can do light dark mode, but it just does the preferences. So I might later on want to implement a light and dark mode for this app. So if you're looking for details while you're night fishing, you don't want a big bright screen in your face. All right, let's look at usage. So this is where I'm really enjoying New Relic. So you can see that I did a NURCL query to gather up the total request counts for my Gemini CLI usage. And you can see I have 2 spikes right around 210,000 tokens. But if I zoom out, it aggregates them. So I see on that day, I used 521,000 tokens. Now, based on my math, that's more than 200. So therefore, 521 more than 200, I would have spent about $2.50 for a million, or was that $1.75, because I used about $500,000 in tokens. So based on the pricing, and that's just input tokens, it's not counting output tokens. I'm just looking at the tokens as an aggregate. Output tokens are a lot more expensive than input tokens. See, it's like $15 when you're over 2,000 for those. But that was what's neat when I checked my bill. What we see here is that my Gemini bill was just 19 cents. And I gave it a day, right? This isn't the day of, and it didn't calculate stuff. The reason why it was 19 cents instead of $1.75 is simply because of all those caching, right? And that's where I'm really enjoying Gemini CLI and Qwen3 Coder. Tools that cache add up. Whereas when I do Claude Code, I pay for Claude Code. Another thing that a good tip is checking your bill. I notice here with the highlighter row that I was paying $4 a month for a static IP to a disconnected Cloud Run function. That's a stupid waste of money. Like, I don't even know what I was thinking. So I was just paying away for an IP I didn't need. Another one that I'll point out is anytime you see the use of a preview model, that's either free or incredibly cheap because it's not released yet. So I always pick the preview models when I can do it. Also, the ones that are called Flash are often really cheap. So Gemini Flash is really cheap, or the older Claude Sonnet 3.5 is really cheap. Another key thing is use free tools. So a lot of times when I was doing this app and I was building it out, I popped over to Copilot. I'm in the free tier. Same thing with Gemini Code Assist. I'm in the free tier. And I'll use an older model like GPT-4o or 4.1 just to help me refine some things. Not really that great at debugging complicated stuff, but quick things. It's fantastic. So, use free when free is there. And there you can see the GPT-5 Nano. Here's another case. So I popped over to Azure, and for my own team at work, we use Azure AI Studio to augment some of our code generation so that we can have some controls. And by deploying GPT-5 Nano, I do get the GPT-5 model, but in the Nano format, it's a lot cheaper. So we can serve all my team's coding AI needs for a couple of bucks a month. And it's a huge price savings. And the only thing with the Nano is because it's a smaller model, it's not as good as the main one, and it's a little bit slower because the way it's deployed, but not terribly slow. Here in Gemini, you can see that 2.5 Flash right there, so you can pick your Pro or Flash models. Another one that I'd like to point out is I'm in the free tier of Copilot a lot. And what you'll notice is you always get the Flash and the Sonnet models, but sometimes, and this is a sometimes thing, it's not an all the time thing, you'll see something like Gemini 2.5 Pro preview. So when Google's rolling out the preview, they must give a discount, probably to try it out. Maybe they're learning off your data. But the point is, when I see the preview ones in here, I jump on them because like GPT-5 Mini was preview for me at the time I wrote this, probably isn't now. And that gives me a new model with current data in the free tier. All right, Qwen3 Coder Plus. I like Alibaba Cloud. They are a fun kind of weird. That's how I'm going to put it. It's just different. You can get 1 million free tokens with Qwen3 Coder Plus. The prices are similar to Gemini Pro. They're a bit higher, especially on the output tokens. But for Coder Plus, which is what I want to use, you do need a paid billable Alibaba Cloud. So you're going to have to put your credit card into this site hosted in China. So you decide what your level of comfortability is with that. But once you do, you get to pick an endpoint. At least for me, my only regions are Singapore and China, Beijing. I tend to use Singapore, no preference there. I don't talk anything politics or anything like that in my code, so I don't know if that would have any bearing. But I've been using the Singapore endpoint. And the way it works is their Qwen3 Coder, because it's based off of Gemini CLI, we're just going to pretend, by and large, that we're using an OpenAI endpoint. It just happens to be going to Alibaba Cloud. So I'll get an API key, which you can see there. And what I do is I set it as an API key, OpenAI API key, and then I use their aliyuncs.com. That's their endpoint for ingesting AI traffic. And then this is where I can set the model of Qwen3 Coder Plus. Now, because it was based on Gemini CLI, its settings are the same. So here I pointed an ingress through my external load balancer in my network over to my Kubernetes cluster. So this is routing all traffic coming into my house through my load balancer in K3s onto my Alloy collector, and my Alloy collector then sends it onto New Relic. So let's give Qwen a try. So we'll cat the settings. We'll set all the values. I've already done the export. I'll launch Qwen. Now sometimes it fails to pick up those environment settings. You could just log in and paste them in. I'll obviously pause the video while I do that because it shows in plain text. But now I'm logged into Qwen. You could tell that I'm in the real professional one because you can see the Qwen3 Coder Plus right here. So I'm going to ask it, as I said, I'm running with npm dev and Node.js 20, LTS iron. Make me a Docker file. I want to start running this in Kubernetes, running this in Docker. And I'll often also ask it to give me steps on how to build and run it, right? So here it's cranking away. It's reading the package file. Now, here's what I'm going to give you about Qwen3 Coder Plus. It's wicked fast. I'm not speeding this up, and I'm not pausing the video. This is it doing its thing in real time. It's really fast. I don't know what they have on their back end, but it rock and rolls pretty quick. So I go ahead and let it run. And it created the Docker ignore, which I thought was a nice thing. I didn't ask it to do that, but that makes my check-ins a lot easier. And it updated my git ignore file. I don't let it do the Docker build, though. I want to iterate on that. But if you let it, it can try and capture errors. And here you can see I used about 59,000 tokens out of my free million. So, again, awfully nice response. Now, one of the things I did is I did a Docker build and then I debugged it. You can see I'm using the free tier here of Cloud Sonnet 3.5 to try to work through any issues I had with the compile. I went back to Qwen, and again, I had it building. This time I let it build so it could start to capture the errors and iterate through the problems that we were having with the Docker build. But now you can finally see that it's running. I'm running on port 3000. I did 3003 just so you can see it. And the app's being served up without issue. When I have a Docker build, I want this to build all the time. So I made a GitHub repo. It's live today, BWC Fish app, and I pushed it out there. And you know it. Do I even need to say it? I, of course, use the AI tools to help me build some of this, like the GitHub Actions workflow. However, the Helm chart that I made, as well as some of the other settings to push it up into, say, Harbor, I already had that canned. I don't need to ask it to reinvent the wheel. So I already had a lot of good Helm charts and tweaks to my pipeline. So I didn't ask for any help there. But you can see because Harbor is an OCI compliant container registry, it's got my Helm chart as well as my container image stored there. I also stored it out there in Docker Hub so everybody could have access to it. So you can see it in Docker Hub. But Docker Hub, I don't put the Helm chart in there. You'd have to go to the Git repo for it. So now I want to run it in Cloud Run. I got it running in Docker on my laptop, and I got it running locally with NPM, but I'd like to run it as a serverless function, in this case using Cloud Run, in GCP. So make a GCP one using this Docker file. What GCP is going to do, what Gemini is going to do, is it's going to go out there and start to figure out my steps that I need to build. So we'll make the terraform directory. Again, we started to iterate on it in here. And it even organized the terraform right with the main variables and outputs. So usually your main's your main code, your variables are variables you need to change, and your outputs are any outputs you want to see the output of, including obviously the URL that gets created because it's a serverless function. It updated the README with the steps I'm going to need to do. So here I have the YAML of those steps. And now I can see how many tokens were used. Again, nice savings highlight and how long this took. So now I'm going to go ahead and use the steps that were in that README that I updated to do the auth login and the project set. So I did the auth login and the project sets. I enabled the APIs. Now, the thing I didn't do in the Terraform is the Terraform's designed right now to both create things like the artifact registry and the repo, but then also the Cloud Run service that uses a build that would be in there, and it's kind of a chicken and the egg. I need to create my artifact registry and then put my built container into it, and then I could launch a Cloud Run that uses that built container. So this really isn't a one and done job. So I do tofu in it. So I use tofu instead of Terraform, but for all intents and purposes, those that use the HashiCorp product could use the word Terraform wherever you see the word tofu. So I do tofu in it. It's going to go ahead and create all this stuff. The first time through, it still tried to launch it. I still don't know why, because I told it not to. But then I move on to doing cloud builds. So here you can see I have the repository, because Terraform created that. Sorry, tofu created that, but the Terraform code created that. And you can see that I'm doing a cloud build. Once the cloud build gets done, I can see it made a new repository there, so a new container pushed to my artifact registry. And of course, going back to my artifact registry, you can see it right there now that it's built and pushed. So now I can start to uncomment things. I did have to delete a busted instance in there by hand. I will admit to click ops to delete the busted instance. I went in there and deleted the broken one. There's probably some settings I could solve, but it was just easier to delete that. But what I noticed is once it built, we'll go back here and build. I truly hope in my recording it didn't pick up the music, because there was some background music there for a moment. So it's now creating the Cloud Run service with the built container. Or sorry, it's deploying that, Cloud Run with the built container. Give it a second. And when I see it flip to public access, I know it's completed. So until the health check comes up, it remains private. So now I can open up a URL, paste in that URL. Oops, I had an extra double quote there. Fix that. And that URL is still there today. And it's the same app. There you go. Now that's running as a Cloud Run container. Again, the infrastructure as code, the Terraform code, was created by Gemini CLI, and all that was captured into New Relic. So this is kind of a diagram of what we solved. We built an app, and in doing so, we used Gemini CLI to go to an Open Telemetry collector to New Relic, Qwen Coder to go to an Open Telemetry collector to New Relic. And I did use some Claude Code. Now, Claude Code has the advantage of being able to go right to New Relic, but I'll show that in just a little bit. So here we see the app, and I kind of want to ask it to orchestrate it. So now that I have an app, I'd like to see its data in New Relic. So I asked it, I'd like to add the Open Telemetry instrumentation to my Next.js app. I'd like the endpoint to come from an environment variable, in the case of Docker, an environment variable that I pass in. So I'll admit I started this path, and it did not work. I tried and I tried. So I mentioned Claude Code. Here's where with Claude Code, hopefully you can see that okay, you have the exporter protocol and destination, like New Relic, but you also have OTLP headers. I think they did that just for New Relic. This means Claude Code, like I point out in the diagram back here, can go right into New Relic, bypassing an Open Telemetry collector, which I think is pretty handy. So I'm going to go ahead and try it. What you'll notice is it didn't fix it. It did not fix it. And because there isn't that same caching as Gemini and Qwen, I spent 46 cents for it to not do anything. So that's my thing about Claude Code. It's an excellent model. I like what Anthropic has, but I pay a lot for it. So I only use it when I must. However, I did see some of this data. So let's pause with some of those data that we get from all these clients here. So you can see the Gemini CLI. This is Gemini CLI data coming in to New Relic. And you can see all the data that's collected about our traces into New Relic. Additionally, I can query all the logs, how much logs were generated by all these tools. And you can see right here, Claude Sonnet 4, that came in Claude 3.5 Haiku. That both came from Claude Code. So these are from Claude Code. That was from Qwen3 Coder Plus, and Gemini was right here. So this is just kind of showing you, I now have one dashboard, one place to look at how am I using my AI coding tools? Which ones am I using and which are generating a lot of logs? I can also start to get a spike on token usage. Remember I told you Claude cost me a lot? Well, here I summed up the token usage as Claude, Qwen as Qwen, and Gemini as Gemini. And what we see here is Claude in that time cost me 661 real tokens, whereas the others were just doing little spikes down here. So that's a pretty important metric, is to compare them side by side on your tools. I did end up instrumenting this, and this is where I want to talk about how. I'm a programmer. I did it by hand. AI coding tools are great till they're not. And when they stop being great, you stop, you follow some Hello World guides, you do some Stack Overflow research, you revisit it a few more times, and then you instrument it yourself. And then you ask the AI tools to just help you with some bugs if you get any compile issues. But ultimately, I instrumented my React code a little more directly. And again, I started by just hard coding the API key in there, and then solving it later. So here you can see that I essentially have an init file that kicks in before it starts next. And this is what handled my instrumentation. And I know that it's working because when I run it locally, I can see that exporter going to the New Relic endpoint, because my default, if I set nothing, was, well, here it isn't, but in the other code it was a local host. So you can hear it's exporting to New Relic. And now I can start to see my React apps data in New Relic via Open Telemetry. So this is an instrumented app. It's showing me the pages you get, the trace counts. I can see the durations. I can start to see all the spans that came in a short window of time. So I got a spike of about 166 in doing a test of just poking through the app. And when I look at logs, I'd see logs if I sent them. Now, I didn't set logs in my React code. I could have, but I didn't. So this is something I chose not to do. Next, here's that init file, and you'll see that I'm now starting to pass in an endpoint and API key. And the reason I'm doing this is so that I can do it with my Helm chart. So you can see first with Docker run, I'm going to go ahead and pass it in the New Relic as well as my API key and launch it. And I'll know from the output that it worked. I then updated my Docker or my Helm chart and made it environment variables that would work. And now when I build the container and push it, sorry, this is the Helm chart, apologies. One of the problems I found with the Cloud run is even though I set it as environment secret, so you can see that I set secrets. So I did infrastructure as code to have some secrets, and I told it, create these secrets right here for the endpoint and the API key. Then once the secrets were created, I set their values. Here's the values that I've set into GSM. And I told it, okay, now that I have these, add them as environment variables on the Cloud run itself. And the first time it ran, I got an error. IAM permissions, kind of forgot about that. Silly me. Cloud run has to be able to see them. But once I solved that and launched, they were in there. But the problem I kept coming up with is it didn't show me Open Telemetry. And the logs kept showing me going back to the default value I had in Docker, which was localhost. And every attempt I made, Cloud Run was not picking up those mounted environment variables. I don't know if it's because Cloud Run compiles the container first and maybe it had a built-in variable at that time. But I know Helm worked, right? So Helm worked, and the container works with passing it in through a deployment. So Cloud Run should have worked. So in the end, what I cheated, this is me cheating, is I hopped into my source code and I hard coded the values in the source code and did a quick cloud build. So I know that they'd be right in there because it's only going to be in my GAR, my Google Artifact Registry. So I got up into GAR and then I launched it and then it was fine. So I'm going to take it as a mulligan that I don't know why the trace URL and API key weren't passed in, but it worked in Kubernetes, didn't work in Cloud Run. I got my trace data. So here you can see me Helm upgrading it. I pass in the API key. I launch it. I can see that it launches, and I can see it's got my new endpoint. So Helm was working. And again, I wanted to do an ingress. That was the other reason I did it. So I created a Google DNS entry in steeped space. And once my Google Cloud DNS entry, and I already have a cluster issuer in Kubernetes that can get a cert from Cert Manager, I got a proper domain name for my app. So bwcafish.steeped.space, I always have a coffee theme, is a valid app with everything in there. And those traces also go into New Relic. So I can go into New Relic and see my trace data for the app right here with how long things are taking. So what does that mean? What do we end up here with? A lot of stuff. In summary, my users, or my developers, me in this case, can use Claude Code and go right to New Relic. I can use Gemini and Qwen and go through an Open Telemetry collector like Grafana Alloy, or the standard Open Telemetry collector, and send up to New Relic. My Docker running in my network, either in my home lab or on my computer, can go to that Open Telemetry collector where it'll enrich the data and send it out. Kubernetes can go to New Relic once I've instrumented my code because the API key is in there. I can have Tofu, which I created with Gemini, create my cloud build, my GCR or GAR. I think GCR is dead now, so it's now just Google Artifact Registry. And my Cloud Run instance. And Tofu is authenticated into GCP. So then it creates the infrastructure, it launches, and I can also send all the data from Cloud Run into New Relic, meaning New Relic becomes my central clearinghouse of data. Some of the takeaways, if you'll afford me a few notes, careful with your API keys. Even though I thought I was very good about not checking anything in, and the reason I'm showing this is because I've expired it, I checked into my public GitHub repo a New Relic API key briefly. I immediately got alerts from Dependabot and from GitGuardian, which, I don't know, they scan public stuff and harass you. I'm glad. But I immediately did that and resolved it as secret now rotated. So careful with your API keys. The other one is when to use API tools. If you don't mind the speed hit, or you have a much better computer than I do with a big, beefy graphics card, you can use local OLlama. And so I do things like use OLlama to create some code snippets. Like you could ask to make a Helm chart. The other one is you can use things like continue dev. So continue dev lets you talk to OLlama, and here you can see I'm talking to Qwen3, an 8 billion model, an 8B model running on my PC with a decent graphics card. Another thing I like is that we can review all of our data in New Relic. So I like being able to hop into New Relic for APM and see a mix both of my build tools, Claude, Qwen, Gemini, and my apps like this BWCA Fish apps. Yeah, I think I covered what I wanted to cover. We had the New Relic and the Open Telemetry. I think hopefully you got some value out of all these presentations. I will have links to the GitHub repo with the app as well as the app available. And thank you so much for allowing me to present. Have a great time.